All right. Afternoon, guys. How are you going? I know I'm standing in between you and lunch, so I'll try and make it relatively snappy. I'm just going to let Arian plug in and have a look. So, real pleasure to present to you guys this afternoon. We're here to talk about some advanced AWS patterns. So I'll just reintroduce myself. So John Painter, the Managing Director of ASEAN for Source. I'm joined here by my colleague, Arian Van Zyl, who's a consultant here in our Singapore office. So we're a global boutique consulting organization that have offices in Singapore, Sydney, Toronto, Vancouver, and Kelowna. And we really have a really strong focus on FSI organizations. So as a global boutique, we have a core focus on FSI. However, we have a number of clients in sort of some adjacent, highly regulated markets, such as aviation, healthcare, telecommunications, utilities, et cetera, et cetera. So what we're going to do here today is I'd really like to take some of your time to present 3 key learnings that we've absorbed out of these kind of highly regulated FSI organizations, and I'd like to present them here today to you. Now, there's a few really interesting things I'd like you to do. We are really focused here on trying to provide some really demonstrable patterns or demonstrable patterns that you can take back into your organization. We've got a live demo, which is always relatively ambitious, so stand by on that one. And these are really patterns that I'd like you to be able to absorb and to take back. So these are really highly actionable insights that I'm hoping you'll get out of this. Okay? So how are we going with getting everything logged in?
A few more minutes.
A few minutes? Okay. So the first pattern I'd like to talk to today is acceleration through automation. Okay? So what we're actually going to do today is I'd like to talk about how we run applications in the cloud. So obviously when we move into cloud computing, we have a whole range of different methodologies and techniques we can utilize to run our applications, okay? And as you're going to see today is cloud computing has fundamentally changed some of the primitives and some of the underlying principles around how we can build and run applications and how much velocity we can gain out of doing that. So at the very core of it, we can take and utilize different approaches that we wouldn't necessarily been able to do on-premise or in some of the more traditional environments. So we're going to do a live demonstration of that here for you today. Okay? We good? Yep. Cool. So without any further ado, we actually have a live demo prep. You can pull out your phone if you really want to. You can go to summit.demo.source.cloud. And what we're going to do over the next 5 minutes is we're basically going to do a live, no outage update of this application on stage, okay? And while we are doing this, I'd like to discuss and present to you the technique that we are using to be able to deliver this change to the application, okay? So without further ado, I'm going to go past Arian, who's going to basically kick off the first part of this demo. We're going to come back and have a bit of discussion about the technique, and then we'll do the actual release for you. So if you really feel like it, you can follow along on your phones, although we'll have it up on the screen as well. So if we can flick over to the presenter laptop, and I'll hand over to Arian to show you the technique now.
Great, thanks, John. Hi, everyone. As you may remember from the slides, my name's Arian, and I'm one of the consultants based here in Singapore. Today's actually my first time being on stage at Summit, so I'm very excited, and it's a real pleasure to be able to present to all of you today. What you see on the screen now and what you will have on your phone or your device if you entered the address that was just up on the screen is an application we developed specially for today. So the goal of today's demo is to deploy a change to this application live with no outage in less than 5 minutes. Before we move on, I'd like to point out that this is a highly available web application, which means it's deployed across 3 availability zones here in Singapore, and it's fronted by one of Amazon's managed load balancers. The reason that this is important is that this represents a very common and best practice pattern that we see throughout enterprises for a wide range of applications. So what we're showing you today is not just limited to web applications, and it's not just limited to demos. So to get started with the application change we're doing today, I'll switch over to the editor view. So the first thing we'll change is the text at the top of the application. So we'll change it to say, we'll change it to say Summit Live Demo. And the next change I'll make to the app is to give the app a little bit more of a local feel. So I'll change the background to an image appropriately named Singapore. When I now commit these changes, they'll be automatically detected and deployed by our automation. For this particular app, the deployment process will take a few minutes. So we'll come back to the demo, but while the automation is running, I'll pass the stage back over to John, who will explain some of the motivations behind adopting native automation techniques, as well as introduce the specific technique that's being used by our automation in the background as we speak. So if we can switch back to the slides, and I'll pass it over to you, John.
Cool. Thanks, Arian. So while I talk over the next 4 minutes, we're basically going in the background, well, actually up in Amazon, of course, we're basically going to be deploying a new version of this application, right? And that might not necessarily sound particularly unique, especially for those of you who've got sort of configuration management or are using other tooling. But there's a very specific technique we're using here that I'm going to introduce to you today. But before I do that, let me talk through what some of the traditional approaches are and how we've taken a different lens with this. So if I look at some of the application migration modes that we can utilize in the cloud, right? On the far left-hand side, we've got a mode that you may call standardized, right? Which is really where you're thinking about application in terms of servers and storage and load balancers and really kind of primitive elements that make up an application, primitive infrastructure elements, okay? And you will receive some benefit of moving to the cloud and utilizing that particular application mode. So there is typically a cost-saving benefit of running on-prem. There may be a performance benefit and an availability benefit with utilizing some of the services, but you're not necessarily really gaining that really high tempo application modes, or you're not necessarily gaining some of the operational savings. In the middle, there's a mode that we call automated, and automated is where you start to leverage some of the Amazon services to provide operational outcomes. So as an FSI organization, you really care about the cost of running your applications. So your day 2 cost. How much does it cost me to make a change to my app? How long does it take? How many people are involved? How many pieces of processes are there? In the automated mode, you start to leverage some of the native Amazon tooling to do things like autonomous healing, autonomous deployment. There's a technology that I'm sure many of you are aware of called auto-scaling, which is traditionally used to make applications breathe in and out, but deployed in a slightly different mode, it can actually be used to automatically heal applications in place with zero human intervention. On the far right-hand side of the scale, we've got a mode that we will call dynamic. Now, that's what we're going to show you today, or it's actually building live behind us. So the dynamic mode is where we really leverage some of the unique attributes of the Amazon platform and some of the unique commercial proposals that offers us to build effectively a brand new way of deploying applications. Okay, and it's very application defined. So you can see on the left, it's more infrastructure defined. I want to build servers and I want to build storage and primitives, and the right are really application defined. So let's talk about how you may have traditionally approached this problem. So there's an app, you know, the summit.demo.source.cloud, and that app is currently running on a bunch of servers. You've got load balancers, you've got servers, you've got some storage, et cetera, okay? Now, how would you have traditionally updated this application? Well, you may be using some tooling. Even if you're using tooling or not, you would traditionally have reached into that existing running environment and patched it in place. So you would have updated the artifact that was running on that existing server, or you may have updated, you know, the specific the code or the files that are on that server. So to update in place, as we all know, requires a lot of testing because this is your production environment. You've got customers on there. You can't just push some change in without understanding whether it's going to work. So you have to really test that. And that requires all those additional environments and all that additional sort of time and effort. The second thing, as you know, is we have to have a roll forward and a roll back procedure because if we do deploy a copy of this application and it fails for whatever reason, we have to be able to fail back quickly, okay? So those two things combined, as I'm sure everyone is used to in this room as highly regulated FSI organizations, means you're really doing this stuff late at night, right? You're taking outages on applications, you're doing it late at night, you're doing it with skeleton crews or on weekends when you have very low customer demand. Okay, so that also means your development teams aren't necessarily on call, or they're getting really tired by being woken up every weekend. So what's changed? Like if we move to cloud computing and we move into the Amazon platform, what's changed? Well, the first thing is that infrastructure is now built in seconds, increments of seconds. So it doesn't really matter if I build something and I throw it away because I've really only paid for a day, a week. We're talking dollars here, right? The other thing that's really important here is the environments can be built in minutes, right? Which I'm hoping, if I've stalled for time correctly, has happened. So basically, the environments can be built in minutes. So we can stand up as many environments as we want in minutes, and you only pay for that amount of time that you're running those environments. So does this present us with a new opportunity? Yes, it does. So here's my existing running environment. Instead of interrupting that running environment and presenting risk to that environment, I just build a whole new environment. New load balancer, new servers, new storage, whatever you want. It doesn't matter what that architecture is. In order to release that to my customers, I simply point DNS or point like a traffic pointer, or if you're using containers, there's a few different techniques here. I release that environment by moving that pointer across, okay? And at that point, all your users are basically now running on the second version of the app. Two things that I'm sure you could recognize here. The first thing is that I was under no obligation to use that next environment. If I built it and it was wrong for any reason, I could have simply thrown it away. The second thing I hope you'd note here is the existing running environment still exists. So at any point in time, that 60 seconds to roll across, I could have taken that same 60 seconds and taken it to roll back. So huge reduction in risk of release. Now, the impact of that, what's the impact? Why do we care about this? So this should really help to unlock high velocity updates. We're going to show you some metrics in a minute, and Arian will walk you through the results of this. But most organizations, because of the reduction in risk and the ease at which we can do this, 5 minutes, you see a much, much higher velocity of updates for your applications. The second thing, like I said, is we're reducing risk. If the environment's not correct, tear it down. If the release didn't go well, roll back. We've made that risk question a lot smaller. And we haven't had to have huge amounts of process to be able to achieve that. So I think I'm getting the thumbs up from Arian. It's all good. So without further ado, we're actually going to do the live release here. And again, if you've got that running on your phone, feel free to whip it out. And yeah, I'll hand over to Arian now to actually do the release.
Great.
So we can flip the presenter back to, there we go.
Perfect. So as John mentioned, right now we have two environments deployed side by side. So I'm going to trigger release by clicking the release button. And I'll actually switch back to the application view so that we can start refreshing as soon as the release finishes. So now that I've triggered the release, the automation will begin switching the friendly domains, so summit.demo.source.cloud, from the current blue to the new green stack, which contains the changes we made at the start of the presentation. So the change to the text and the change to the background. So this release process takes about a minute to complete. And while this is happening, I'll quickly take the opportunity to do a bit of a deep dive into some of the advantages of the blue-green deployment technique. So with blue-green, as John mentioned, we actually deploy a copy of the environment in parallel to the existing environment. This means that you can perform all of your testing, so your acceptance testing, your load testing, your penetration testing, et cetera, on actual real environments before they are made live. And because these environments have been created dynamically, if an environment fails a test for any reason, you can simply discard the environment and pay for only the time during which it was active. Being able to test in this manner directly leads to a drastic reduction in risk for your releases. And after the release, with the way that the blue-green release mechanism works with the DNS switching, it means that rollback is now as simple as switching DNS back to the previous stack. Yeah, so this gives you a massive reduction in complexity compared to the traditional lengthy manual rollback procedures, and again, a reduction in risk in your releases. So all of these factors, they help you unlock developer agility and velocity. And from our experience, this inspires a culture of innovation. So by now, the release should have completed. So if we reload the app, and I encourage you to reload the app on your phones and your devices, we should hopefully see the changes reflected, and we do. There's beautiful Singapore.
Well done.
So thank you. So just to sum up the demo, what we've just done is we've leveraged automation and native deployment techniques, specifically blue-green, to push out a real-time change to our live application with no outage within a time span of about 5 minutes. If we could go back to the slides, I'd like to show what this looks like when we introduce these kinds of techniques to our clients. So the first example is of a large regulated Singaporean enterprise. So they traditionally performed monthly releases. Upon adopting native deployment and release techniques, we saw that they were able to perform 48 development updates and 24 production updates in the span of 3 months, which is 16 times more than was previously feasible. Another example is from a large local FSI. So this particular application was deployed from the very beginning using native automation techniques. And what we can see is that they were able to perform 400 discrete deployments in a period of 7 weeks and perform approximately 70 production releases. What's even more interesting is that they were able to gain so much confidence in their application and their deployment and release mechanisms that after just 2 weeks into the project, they were able to perform their first production release. And this is by no means isolated examples. In fact, we see these sort of upticks in velocity in every single one of our clients. So I think it's very fair to say that embracing native build and release techniques, such as the blue-green technique that we demoed today, can lead to substantial increases in velocity. I'll now pass it back over to John, who will talk to you about the benefits of leveraging real-time compliance.
Cool. Thanks, guys. Thank you very much, Arian. That was pretty awesome. So 2 last patterns I'd like to talk about really quickly. And again, this is bringing back a little bit more of an FSI-oriented lens. So you're hearing a lot today about, let's move to the cloud and let's, migrate our applications to the cloud. And we know, as a highly regulated FSI organization, we need to really care about how we do compliance. So I want to give you some direct patterns here. So the first thing is AWS has a really broad and deep range of compliance services that you can leverage. So not only do I want to describe the services, I want to describe to you how we can actually utilize and build an effective technique here. So we've got CloudTrail, which basically has a complete audit trail of all the API activity. You've got things like Config, which can look at the status of your underlying servers and infrastructure, all the way through to CloudWatch, we can provide time series data and metrics. So the first thing we need to do is we need to get all this data into a single place, a single source. So here's your account landscape across your entire estate or portfolio of accounts. So whether these are production, non-production accounts, POC accounts, different line of business accounts, even different region accounts, doesn't really matter. Right? The key here is to get all of that data into a centralized compliance bucket. The great thing about doing this is that most of these services are free and or extremely low cost, so there's no reason that we can't sort of ubiquitously deploy this across all of the accounts. Now, once we've done that, I want to talk to you about the different techniques for how we can actually monitor and regulate that compliance activity. So once we've got our bucket in place and we've got all this data firing into it from all these accounts, you've got 2 choices, right? We can go sort of the semi-traditional route around what we'd call, reactive monitoring. So reactive monitoring is your traditional approach of having, a dashboard with a series of alerts with a series of remedial actions on the back of it, right? And you might have like a big SOC or NOC that's running that. I want to show you today how we can actually build another mode on top of that, which is real-time compliance, which is an event-driven, autonomously applied remediation platform. So let's firstly look at the first mode. What does the first mode look like, which is reactive monitoring? So it's relatively simple now, almost to the point of absolute commoditization, that you can get dashboards like this. There are a range of providers, and SaaS providers especially, that can offer this at a really, really good price point, right? Where basically you've got all that central compliance data, and you can do real-time monitoring and dashboarding of that data, okay? So in this case, it's highlighting some out-of-band firewall changes and some failed console logins. Now, the thing I want to look at here is, well, how would we respond to those events? So we traditionally would have some kind of observer or some kind of NOC that was running, and they might have a bunch of tickets or alerts that are raised, and then we have our standard React and remediation activities, where you might have a human-led change, or you might have a semi-automated or somewhat automated workflow on the back of that. And of course, they're instrumenting that through tickets and or some kind of semi-automated workflows, and they go and fix the problem. How can we enable real-time compliance? How can we get really, really sophisticated around this stuff? So the first thing is that that compliance bucket natively can fire events into Amazon Lambda. Now, Lambda, as you know, is a service that will basically run a small segment of code for you, okay? And we can effectively have all of that compliance information landing into that central bucket. And as that compliance information lands, we've got real-time landers that are then applying autonomous remedial actions, such as shutting down a security group, locking out a user account, et cetera, et cetera. The key learning here is they're real-time and they're event-driven. The second thing we can do that's really interesting on the back of this is, because this is Lambda, it's highly instrumented. So we can actually instrument the Lambdas firing to know how many compliance activities or how many remediations we're taking. If we then kind of categorize this as in, let's say, 5 firewall changes a week is normal, 10's unusual, and 50 is very unusual, what you can now do is effectively have a summary indicator or like a DEFCON panel for how healthy or unhealthy your cloud is, right? Which I think is pretty cool. So for example, we're in a low, medium, or high state of alert depending on how many remediation actions have had to be taken on our platform. I've seen 400 failed user logins. That may indicate they're in a really high state of alert currently. And of course, it's Lambda. That means we can get a very high degree of ticketing and alerting and instrumentation on the back of that. So that's our suggested pattern on how we could really start to leverage and enable real-time compliance and really give you a lot of confidence that these accounts are always in a very healthy and clean state, irrespective of what your users are doing inside those accounts. Now let's talk about the user experience. The last trick, and this is probably the biggest learning that we've walked through over the last couple of years, is how do we help people move to the cloud whilst they're compliant by default? Because the challenge is, of course, as a regulated entity, we have to make sure that the things we're deploying are compliant. There's a whole bunch of rules, instrumentation, logging, alerting, failover that we really care about, okay? So let's look at how this is traditionally done. In our experience, most FSI organizations will have something that looks approximately like this, where applications will come to you and they'll say, hey, this is an app I want to build, and this is the pattern that I want to build, and these are the services I want to use. And some kind of review function, some very large, some are very small, but it doesn't matter. Some kind of review function will say, yep, we agree with that, okay? Now, of course, this presents some challenges. There's 2 challenges. Well, the first challenge is every time you change something, you've got to go back through that process again. And I'm sure, many of the room have experienced that become a very cumbersome and very, time-consuming process. And it puts a lot of load on those review individuals, the people who are responsible for signing those decisions off. So that's the first problem. Every single change requires a repeat of the process. The second problem, as we start embarking on mass migration of applications into the cloud, is you've now got basically all these applications coming to you saying, I want to use these services and I want to do these patterns, et cetera, et cetera. So that review board's getting bigger and bigger and bigger. So what we effectively have is we have a linear relationship between the number of applications that need to be signed off and the number of hours you need to actually complete that activity. And as you know, anything that's in a linear relationship doesn't scale very well, right? So those review boards just get busier and busier and busier to the point of either restricting the amount of throughput you have or failure. The thing is, however, is those review functions have a really critical part to play in the eyes of the business, right? Well, what do I mean by that? Well, they're really there to make sure that these applications meet the right availability, durability, and scalability goals as it pertains to your application. Okay, now you might know these by some different acronyms, right? So like RTO and RPO, how fast can my application recover? How much data loss am I willing to sustain over a point in time, okay? But these review boards are really there to make sure, okay, well, this application is highly available and the data will not be lost and we can scale for our customers, right? The second thing these functions commonly do is they're responsible for making those decisions according to how important the application is for your business. So as we know, a Cat 1 or Tier 1 application, right, which might be a principal application for the business or a principal revenue generation or basically a regulated application, right, they have extremely high expectations of availability, durability, and scalability. They cannot fail, they have system of record data, and they have to be able to scale to thousands, if not hundreds of thousands of users, if not millions of users. But as we move down that, you've got different systems inside the bank, right, where it might be business essential or you're doing batch processing, where the availability targets don't need to be as high. Your durability, is almost always very high in a banking organization, but maybe the scalability, it's a back-end batch, you don't have hundreds of thousands of customers. So what we have here is a bunch of categorization, right, and a bunch of those metrics. So the question I ask everyone is, has any fundamentals changed in cloud computing that helps highly regulated FSI organizations accelerate this process, which is this sign-off process? How do I get compliant by default? And the answer is yes, one thing has changed. One very, very core fundamental thing has changed. And that is that the degree of standardization has drastically increased. What do I mean by that? I mean that my account, your account, right? Different accounts between different regions, different accounts between prototyping and production, they're all the same. The services that you consume from those accounts are the same. So I'm able to certify something in my account, and I know that it's globally applicable, whether or not you're production, non-production, and which regions you're in. So the degree of standardization has drastically increased. Let me show you what I mean. So if I just take an instance in my account, an instance in your account, an instance in his account, I can say with very high degree of confidence that that has a low availability, a medium durability, and no scalability, right? It's only in 1AZ, the data is only replicated to 1AZ, and there's no scalability, it's just a single server. I take a pattern like this, where I've got load balancers and I've got multiple containers or I've got multiple instances, I've got the right level of instrumentation, all of a sudden my availability, scalability, and durability have gone up, right? It's now spread across multiple AZs, the data is now replicated potentially across multiple AZs, and my scalability is increased. I move on to other services such as RDS, right? Amazon's doing a whole bunch of undifferentiated heavy lifting underneath there to try and increase, again, availability, durability, and scalability. And if you use those native services, you get a lot of that stuff off the shelf for free. But again, you can see here that, that choice to use that particular service gives me these criteria. Move on to some of the really native services, like Aurora and DynamoDB and Lambda. And again, Amazon's done a lot of engineering on the back end to make sure that they're meeting the highest standards, right? So what can I do with all this information? How do I get compliant by default? Well, here's the trick. All I need to do now is I say, for my tier 1, category 1 applications that have systems of record data, right, and must be available 99.9999% of the time, there are specific patterns that I'm allowed to use, right? I'm allowed to use the thing that was highly available and had all the load balancers involved. If I'm a POC app that's sitting in a dev account, right, then I can use more patterns. I can use the single servers, and I can use those and experiment with those for a point in time, such that I can get the application moving and then move up into the patterns that have those higher degrees of availability, scalability, and durability. So here's the change. Here's the critical shift. The critical shift is that review board can now certify the pattern, as opposed to certifying the application on a one-by-one-by-one basis, okay? And what that does is it completely unlocks that ability to say, okay, if you meet this particular pattern or if you have this particular architecture, I know that it does not matter which Amazon account you are in which region, right? Whether you're production, non-production, India, Singapore, I know that you are compliant and you're certified. So it completely removes that linear process. I can have n number of apps, 1, 100, 100,000, and I'm not going to increase the number of hours that we go through that review process. There's a second hidden goal here, and that goal is that this completely unlocks compliant by default self-service, which is the ability for your users to come to a platform and to self-service their needs, right, while getting compliant by default services, as in services that the bank has certified and certified that holistic pattern. Now, unfortunately, with only a 30-minute discussion, how to actually do this is a little bit out of scope. So I please encourage you to come down and visit us on the booth and we can talk about it. There are multiple techniques for achieving this, right? Absolutely. There are multiple ways of doing this, starting from things like registration and discovery techniques through to detective controls. And those detective controls are getting smarter and smarter and smarter by the day, with things like machine learning being applied over the top of them. And then finally, on the far right-hand side of that curve, you've got things like directive consumption techniques, right, where you've actually got that detective validation running in over the top as well. So this is an evolving space, requires really careful calibration inside your organization as to which one of these modes you would like to use. And what's really key here is not necessarily which mode you use today, but it's your ability to refresh this decision as it moves forward, because this is a rapidly evolving space, and there will be efficiencies and cost benefit as it moves forward. Okay? So guys, I really hope those 3 patterns gave you some inspiration. I hope they gave you some actionable insight that you can take inside. Please feel free to meet us down on the booth. Yeah, it was a pleasure to present to you today, and thank you, Arian, for kicking off an awesome demo. Thank you, guys.
Thanks, everyone.